Welcome to our machine learning assignment video. Our project is titled Heart Diseases Prediction System. This project was developed to predict whether a patient is likely to have heart diseases or not by using clinical patient data. Heart diseases is one of the major health problems worldwide, and early prediction can help support better medical decision making. Mm, for this project, we used heart diseases dataset, which contain 1025 patient records and 14 attributes. Using this dataset, our group implementation for supervised learning algorithms to compare their performance. Mm, In this video, each member will explain their own contribution, uh, including pre-processing, model implementation, and result. So now let us begin with the first part of our implementation. Uh, I am WID Vijay Singh. My part is data pre-processing and logistic recreation. First, I import all the requested libraries for this task. Pandas and NumPy we use for handling the dataset. Metrolib and Seaborn uh, we are using for visualization, and Sticklearn we use pre-processing, training, and evaluation. Uh, After that, I loaded the dataset using Pandas. Uh, then I display the first few rows, the dataset using the uh, heart function to understand the structure for the data. Uh, Here we can see different features such as age, sex, chest pain type, cholesterol, and heart rate, along with the targets variable, which indicates whether the patient has heart diseases or not. Mm, After that, I use the info function to get summarize of the dataset. Mm, the dataset contain 1025 entity and 14 columns, including both numerical and categorical features. All columns have complete data with no missing values, which mean no data cleaning was required. Next, I performs data visualization to better understand the data set before building the model. Uh, First, I visualize the distribution of the target variable. This graph shows the number of patients with heart diseases and without heart diseases. As we can see, dataset is fairly balanced, which is useful building a reliable classification model. Next, I use a correlation heat map for uh, explaining the relationship between the different features. This helps identify how variables such as chest pain, per type, maximum heart rate, and uh, exercise included are related the target variables. This step is useful for understanding the which features may have a strong influence on heart diseases prediction. Finally, I visualize the relationship between age and heart diseases. Uh, this graph shows how heart diseases cases are distributed across different age gap. If give a better understanding for how age may contribute to heart diseases risk. After exploring the dataset, I performs the necessary pre-processing step. First, I check for missing values and remove them if any were present. However, in the dataset, there were no missing values. Input features are stored in X and the target variable is stored in Y. Next, I split the dataset into training and testing set using an 80-20 ratio. This allows the model to be trained on the portion of the data and tested on unseen data. Since logistic regression is sensitive of features, scaling I applied standardize using standard scale. Hmm. This ensures that all features are not the same scale, improving the model performance. Okay, next I trained the logistic regression model using the pre-processing training data. After training the model, I used to make prediction on the test data. Then I evaluate the model performance using accuracy. The model achieve an accuracy for approximately 79%. Uh, I also generate a classification report which include uh, precision, uh, rescale, F1 score, support. This matrix provide a more detailed evaluation of the model performance of both classes. This completes the logistic regression model implementation. Finally, I visualize the model performance using confirm matrix. This matrix shows how many prediction were correctly and incorrectly classification by the logistic regression model. Finally, I save the clean dataset as a new CSV file for future use.
Hello everyone, I am Sasanka. I will explain the K-nearest neighbors model. First, I import the necessary libraries like pandas and stylams. Then I load the cleanups heat disease dataset. Before making the model, I created a collection heat map. This helpful us how different features are related to the heart disease. Next, I split data. I use 80% of the data for training and 20% for testing. After that, I use standard scalar KNN works by calculating distance between data points. So scaling the features is very important. If we do not scale, large number will ruin in the model. Next, I want to find the best K value. I didn't want to. Next, I want to find the best K value. I don't want to just guess it. So I check error rate of the K value of 1 to 20. Look at this graph. As you can see, the lowest error rate is when k is 5. Because that I trained my final model using 5 neighbors. Finally, I checked the result. Our model got very good accuracy of 83.41%. Here the consecution matrix. It shows the our model make balance prediction with very few mistakes. Thank you.
I am Divishan VK. As part of our heart disease prediction and system project, my individual contribution was implementing and evaluation the decision tree classifier model. First, I import the necessary libraries, including pandas for data handling and scikit-learn for model building. I loaded the clean dataset provided by my team, which contains various clinical features like chest pain type, cholesterol, and heart rate. The data was split into an 80% training set and a 20% testing set using a random state of 42 to ensure consistency across all team members' model. For this implementation, I created a decision tree classifier with the maximum depth of 4 to prevent overfitting while maintaining a clear logic. One of, one of the key advantages of this model is its interpretability. Here I have visualized the actual decision logic used by the model. These are the decision tree logic visualization. Uh, As shown in the diagram, the model uses features like chest pain and maximum heart rate at the top levels to make its primary classification. I also analyze the feature importance to identify which clinical factors most strongly predict heart diseases. In the in the model in my model, chest pain type emerged as the most significant predictor, followed by TAL and CA. This helps us understand the clinical relevance of our prediction model. These are the feature. This is the feature importance of heart disease prediction. Finally, I evaluated the model's performance on unseen test data. The model achieved an accuracy of 80%. The confusion matrix shows that the model correctly identified 71 health cases and 93 heart diseases cases. The classification report indicates a good balance between precision and recall, specifically a high recall of 0.94 heart disease detection, which is crucial in a medical context. This is a predicted table. This concludes my individual contribution. Thank you.
I am WI Udan. Next, I implement the random forest model for the heart disease prediction. First, I import the all required libraries such as Panda, NumPy, Matplot, Seaborn, and machine learning tools for scikit-learn. Then I loaded the cleaning dataset using Pandas. This dataset was already pre-processed by the previous member, so no additional cleaning or scaling was required. Next, I separated the feature and target variables. Here X contains all input features and Y contains the target variable which indicate heart disease. After that, I split the dataset into training and testing set using a 80 to 20 ratio. I used the fixed random state of 42 ensure consistent result across the all models. Next, I performance hyperparameter turning to find the optimal number of trees for the random forest model. I trained multiple models with different number of trees ranging from 10 to 140. This graph shows the relation between the number of trees and the model accuracy. As we can see, the accuracy improves and stabilizes as the number of trees increase. Based on the result, I selected the 100 trees and trained the final random forest model. After training the model, I used it make prediction on the dataset. Then I evaluate the model using accuracy. The model achieved an accuracy of approximately 90-80%. I also generate the classification report. This includes precision, recall, and F1 score, which given details understanding of model performance and both classes. Next, I visualize the model performance using confusion matrix. This shows how many predictions we are correctly and incorrectly classified. It helps us understand how well the model distinguishes between patient with and without heart disease. After that, I analyze the future importance in the random forest model. This graph shows which features have the most influence on prediction heart disease. Features like chest pain type, maximum heart rate, and other medical indicators play a significant role. Finally, I compare the performance of all models. This chart shows the accuracy of logistic regression, k-near neighbors, decision tree, and random forest. We can see the random forest model performs very well compared to the other models. This completes the random forest model implementation.